Hello everybody, we are back with 7.1. Today we're going to be talking about polynomials, which will be super fun. Before we start with polynomials, we need to start talking about monomials. And before we talk about monomials, we need to make sure that we have all of our vocabulary down for what we're about to start discussing. So a number that is in front of a variable is called a coefficient. Now, I've used that word a lot. I don't think I've very explicitly said this is the definition, this is what a coefficient is, but the number before the variable is called the coefficient. I said that a lot when we were talking about linear equations, and I was trying to get you to find the slope. The slope is always the coefficient before the x term in a linear function, so coefficient. If there are no numbers in a variable, so let's say it's just an x, or just a y, just a z. A 1 is understood. There might not show coefficient of 1, but if you have a single variable, a coefficient of 1 is understood. All right, there are 1 x's, there are 1 y. All right, so now let's talk about polynomials and monomials. They are made up of an algebraic term, which is a term that contains one or more variables, as well as constant terms, which is a term that only consists of numbers. Alright, so right below here in A, B, and C, I have some polynomials. Now, polynomials are made up of multiple monomials. So, for example, this right here, this 2ab, is considered a monomial. It is one term within the polynomial. So let's take a look at A, this polynomial, and let's just circle coefficients and put boxes around constants. That way we know for a fact, we understand the vocabulary, and we can move on from there. Alright, so what I'm going to do is put red circles around coefficients in part A. Okay, so coefficients, according to my definition, are numbers that come in front of variables, so that are multiplying variables. So right here, I have a coefficient. Now, some people might be tempted to put a circle around here as well, but this 4 is not multiplying any variables. So technically, this 4 is what we defined as a constant, which is a term, a single term, that consists only of numbers. Alright, now when I go over to B, I'm going to start with constants, since I already have the blue selected. So if I look at my first term is 2x. That doesn't look like a constant because there's variables in there. My second term is a 9, so yep, I'm going to put a box around the positive 9. And then my third term is negative 3x squared, which again has variables in it, so not a constant. Now I'll switch over to red, and I'll do my circles for the coefficients. My first term again is a 2x, so the coefficient here is the number multiplying the variable, 2. And here I have negative 3x squared, the number multiplying the variable is a negative 3. That is my coefficient there. Keeping the positive and negative values connected with the number is very important, especially when we start combining like terms and switching parts of the equation around. So now let's go to part C. Actually, I'll stay on red. We'll do coefficients first. My first term here is pretty big, negative 10 abc squared. So still the number that is multiplying the variables is a negative 10. Just because this monomial here got, more expansive and more complicated doesn't mean that the definition of the coefficient changes at all. My next monomial here is 5a squared bcd, so even more complicated, but still it doesn't change the fact that the definition of the coefficient is the number in front of the variable, multiplying the variable. I go over to my next term, which is a 32. Is 32 a coefficient? Well, it's its own term, and it looks like it just consists of numbers, so that's actually a constant. And then over here, my last term is a to the fourth. Now you might be thinking, oh, there's no numbers there. I don't need to circle anything. That's not exactly true, because remember, if there are no numbers in the variable, a 1 is understood. So the coefficient here is -1. Okay, we need to be sure that we are aware of that. And lastly, I will put a box around my constant term, -32. Okay, so now let's move down a little bit, talk about what makes a monomial. Because I kind of just jumped right into these things and I said these are all polynomials made up of monomials, but let's pump the brakes for a second and figure out exactly what that is. A monomial is an algebraic term consisting of one term that is a constant or a variable, or the product of constants and variables. So it could either be a number, a constant, like the number 5, or it could be a variable, like x, or y, or z, any variable, or it could be the product of constants and variables. A single monomial could be something like 5x, y, z to the third, q. I'm just making that complicated just to show it's the product of variables and constants. Okay? So a single monomial is one single term. The polynomial, and why I said all of these are polynomials, is because these have been connected. It's a whole bunch of single monomials. Like we just said, a monomial can be a constant, like a 4. A monomial can be the combination or the product of constants and variables. And then the polynomial is a combination of all of those things pushed together through addition and subtraction. But we'll get there in a second. Before talking about the polynomial, I want to look at something that's called the degree of the monomial. The degree of a monomial is the sum of all of the exponents in that particular monomial. So, for example, if I go up here, and like I said, this whole thing is a polynomial made up of two different monomials. So I could find the degree of both of these. This right here has just a single constant value, so it doesn't have a degree larger than 0. In this case, I have two variables, each raised to the first power. Remember, just because it's not there doesn't mean that there's no number. A to the first, b to the first, the sum of the two, the degree is 2. Here, I have a polynomial comprised of 1, 2, 3 different terms. So in this monomial, the degree is x to the first, so the degree here is 1. This one is 0 because it's a constant. This one here, x to the second, so the degree there is a 2. Now this last one is going to get more complex because there's a lot more variables. They have higher exponent values. So this again is a polynomial comprised of 1, 2, 3, 4 different terms. So I'm going to have 4 different monomial degrees here. The first one is a to the first, b to the first, c squared, so that's 2, 3, 4. The degree is 4 for this monomial. In this term, I have a to the second, b to the first, c to the first, d to the first, so that's 2, 3, 4, 5, degree of 5. Here I have a constant. And lastly, a to the fourth, degree of 4. Okay, so finding the degree isn't too difficult. It's really addition. So now let's talk about the polynomial, the whole entire thing, not just breaking it up into these monomials, or even farther breaking up the monomial into the constants and the variables, but let's look at the entire expression as a polynomial. And that's the sum or difference of monomials, as you might have been able to deduce already, because I have addition in between these two monomials. I have addition, subtraction between all of these monomials, addition, subtraction, subtraction between monomials, creating one polynomial. Right? So a monomial is a polynomial with one term. For example, something like 2x. A binomial is a polynomial with two terms, and you might be able to get all of these from these prefixes, mono meaning one, bi meaning two, and guess what tri is going to be? 3 terms. So a binomial could look like 2x squared minus 3x. Sure, I'm just making that up. And a trinomial with 3 terms could look like 2x squared minus 3x plus 5. Okay? Each of these 3 terms, each of these 2 terms, this term, all are monomials. But when 2 of them are combined using addition or subtraction, it's a binomial. When 3 of them are combined using addition or subtraction, it's a trinomial. But all of these things fall under the category of being polynomials, so many different terms. Okay, so terms of an expression are separated by addition and subtraction signs. So that was kind of just like a whole bunch of information dumped onto you. Let's try and use some of that information and hopefully clear up anything that's stuck in your mind a little bit, bugging you. What we're going to do for practice is use this polynomial, this long term, to answer a couple questions about it. And hopefully we can clear up any problems. So how many terms are in the expression? Well, the terms are the monomials that are separated by addition and subtraction. So I have a 3x, I have a negative 2y, I have a 7z, and I have an 18. So that makes 1, 2, 3, 4 terms. List the constant terms. Well, just like we did up here, the constant terms are the ones that don't have any variables attached. So this is 3x, that's not a constant. Negative 2y, that's not a constant. 7z is not a constant, but negative 18 is a constant. List the algebraic terms. Well, we already separated the constant terms, so the algebraic terms are just everything else. 3x, negative 2y, and 7z. And list the numerical coefficients. Okay, so the coefficients are what's going to come from the algebraic terms, from these monomials, and it's going to be the number that multiplies the variable. So in this case, the 3x, the coefficient is a 3. In this case, the negative 2y, the coefficient is a negative 2. And in this case, the 7z, the coefficient is a 7. Make sure that you feel confident with all of this before we move on to the next page. Okay. Now, up here, what I'd like you to do is it's basically the same type of practice, but with a completely different polynomial. And I'd like you to try and answer all 4 of these questions. It's the same questions as the first side, but I'm going to have you do it completely on your own, and we'll check in next class to make sure that everybody is feeling good about it. Alright, so now what we're going to do is move into, I have a really long polynomial, but some of the terms are what we call like terms, and I've used that wording before, but we're going to kind of expand on it a little bit because we're introducing all of these exponents and things, and we might not be sure what exactly is a like term anymore when we have all of these like crazy monomials. So like terms have the same variable, and we know that from when I say you can combine 2x with 5x, but you can't combine 5x with 5y. But now we're extending it to exponents, so they have to have the same variable and degree. So they have to have the same variable and exponents. So let's take a look at a sequence of different monomials and figure out which ones are like terms. Okay, and I'm going to go ahead and circle some that I can see right off the bat. In A, I have 3b. Now I need to look for terms that have the same variable, so b, but also the same degree. So this is b to the first. I need other ones that have b to the first. This is also b to the first. Different coefficient, but that's fine. Same variable, same degree. 4b also fits the bill. So like terms here are going to be 3b, 7b, and 4b. Now when I combine all of those things, this is positive 3b, positive 7b, positive 4b. So combined all together, it's 3 plus 7 plus 4, 14 b's altogether. Making sense? Now let's look at b here. I have to look for ones that have the same variable and degree. Now this one gets a little bit more complicated because I have two different variables. I have a and c. So this is a to the first c squared. Are there any others that have a to the first and c squared? Well, this is a squared c to the first, so that's almost there, but not really. This is a to the first c to the first. This one is c squared a to the first. Well, actually, that looks the same. A to the first c squared. These are switched, but it's still a to the first and c squared. So that will work. It's being a little bit tricky there. And then our last term is a squared c squared. So other than these two, we don't have any other like terms. I have 2 a to the first c squared, and I have 9 a to the first c squared. And you'll notice that I switched these two variables when I rewrote it over here, and that's fine to do. I'm doing that because it makes me realize that these two things are in fact like terms, and it's a lot easier to see it. So it's just for a visual sake that I'm switching those two. Now when I combine the two, I have positive 2, positive 9, 11 a c squareds. Now, an expression is simplified if blank remain in the polynomial. So what do we need in order for an expression to be simplified? Well, what I was doing here was combining like terms. So really, what I'm trying to get at is that an expression can be simplified if there are no more like terms remaining in the polynomial. So basically, if you combine all of the like terms, you've created as simplified a polynomial as possible. So now we want to look at something called standard form. And it's not going to be as complicated as it probably sounds, because every time that I've come out and said we have to do, slope-intercept form, point-slope form, standard form of linear equations, there was always kind of this format that has to go with it, and it gets a little bit confusing with some of the variables. But standard form of polynomials actually is pretty intuitive. It's just when the terms are arranged so that exponents are in descending order. So, it's nothing too crazy. It's just a matter of taking the degree of each monomial and placing them so that their degrees are decreasing. So in this case, I have 3 terms, x to the 4th, 2, and x squared. The degree here is a 4. The degree here is a 0. The degree here is a 2. So if I want them in descending order, it's going to be x to the 4th minus x squared plus 2. Now this is why before I was saying it's very important to keep the negative or positive value of a specific term with that term. See, this I saw as a negative x squared, so when I moved it, it continued to be a negative x squared despite the fact that I moved it over here and the positive 2 came to the end. Alright, we need to start being very conscious of those types of things so that when we move terms from one place to another, we're not ruining their positive or negative value. Why don't you go ahead and try placing b in descending order, and then we'll go over that one in class. Right, remembering that we want the terms, each monomial in the polynomial, to go from greatest degree to lowest degree. Now let's take a look at number 9, which is going to be more of an application type problem, where we're given this seemingly complex formula that's supposed to represent height in feet of an object, given initial velocity and the initial height and time. So what it's telling me is that a specific height, if I want to find the height of, I think it's a ball that's being thrown up, it can be given to me given this formula that'll express time. But I have way too many variables in there, so I'm going to grab some information from the picture over here and place it into my equation. Sorry, that should be a negative 16. So negative 16t squared, that's my first term. I don't know time, so I can't input time, but then I get to my next term and it's v sub 0, which it tells me is 30. So I can plug in a 30 there. 30, still don't know time. And then plus s sub 0, which it tells me is 4. So this is modeling an equation at an initial height of 4 with a ball that's being thrown with initial velocity of 30 feet per second. And then this right here, this first term actually represents gravity. And we'll look at examples like this in a lot more depth later. But right now I'm really more interested in just using it. So I've written the polynomial. Fantastic. There's no like terms. This one has a t squared, this one has a t, this one has no variables, so no like terms, no simplifying, it's done. What is the height of the ball after 1 second? So awesome, cool, b gives me the time. So now in my equation I can fill in my last variable and solve. T is going to be a 1. 30 times 1 plus 4. Cool. So this is going to be negative 16. And 30 times 1 is 30. It's a 4. And then plus 4. Altogether, 18. What does that mean? It means after 1 second, the baseball is 18 feet high. Okay? If we have any questions about these, please write them down so you don't forget. We can talk about them in class. And we'll go a little bit more in depth as to what a monomial cannot be when we're in class next time.